optimizing significant phases of the baseball swing.
The title of this research paper, published in 2020, is Sequential Order of Swing Phase Initiation in Baseball by lead author Ethan Stewart, now the lead sports scientist for the Oakland A's. Starting with a summary, the purpose of this study was to examine the difference between start times for the swing phases. Those swing phases are shifting, stepping, landing, and swinging. Shifting is the movement before the lifting of the stride foot. Stepping is the forward movement or the stride. Landing is when the stride foot actually lands. And swinging starts when the hands begin the downward movement to the ball. Currently active collegiate baseball athletes with the average age of 23.67 years old were measured utilizing motion capture, surface electromyography, and force platforms while hitting 5 trials off of a tee. The results showed a distinct and statistically significant sequence of 4 swing phases. Optimizing sequential order can help players to regulate timing and generate power. Understanding when and how the sequence of the swing happens can help coaches guide instruction with athletes.
Since we're talking about the summary, I want to show this graph, which I think does a very nice job depicting the summary of what happens in the study. The timelines are on the top of the graph, which show the different time that each phase of the swing starts relative to contact. The graphic in the middle shows the relationship between movement of the hands and lead leg ground force production. The dotted line at the top is the vertical position of the lead hand, and the dotted line on the bottom is the ground force reaction produced by the lead leg. You can see as the dotted line on the bottom goes up, or as lead leg force production goes up, the movement of the hands down to the ball accelerates at nearly the same time. Here's what I think that might look like in real life. The graph is overlaid onto a major league swing where you can see the line for lead leg force production overlaid onto the lead leg of the player. The lead leg is extending or reaching peak extension force around the time the hands are essentially bottoming out. This is the point in the swing where the lead leg has produced its highest amount of vertical force.
In the introduction, 2 main points stood out. The first might seem obvious, but it's popping up repeatedly in different studies. If you're a hitting coach, there's no doubt you've told your players at some point to get started earlier. And starting the swing earlier allows hitters to complete the swing effectively, even as response time decreases. Or in other words, when the pitch speed increases, the player can still effectively execute his swing. So controlling timing of the load is very important. The second point is that more skilled players show significantly earlier starting of the shifting, stepping, and landing phases. Those are the preparation phases, followed by significantly later initiation of the swing phase compared to less skilled players. Highly skilled players start the pre-swing movements earlier, but are still able to delay the forward commitment of the hands in the swing. Now, results of this study showed a statistically significant sequential order of the start times of the 4 phases of the swing. The authors went on to discuss these points. 1, hitters have more preparation time when starting the shifting phase significantly earlier. More time is then available to generate power and optimize the kinetic chain to produce higher bat speeds. Again, controlling the pre-swing movement is very important. 2, starting the swing phase when the bat moves forward allows the hitter to see the ball longer. This is the benefit of power, which is shorter time to contact and bat speed. When your swing is shorter and more powerful, there's an opportunity to see the ball longer and improve both swing decisions and contact. 3, decreased time to contact for successful hitting gives insight into differences between skill levels or between success and failure. 4, suggested future research is to measure the timing differences of the swing sequences in different levels of competition in order to understand the transition between players at different levels and guide their player development progression. Practically speaking, a statistically significant sequential order is evident in the swing phases of these college hitters, and understanding this process can help coaches with both analysis and prescription of coaching methods with players. Keep this in mind. we are dealing with milliseconds. That's 0.001 seconds. And the minute differences can be the differences between success and failure when it comes to hitting a baseball. Understanding the swing timing and sequence can help us with very small adjustments that have the potential to make a significant difference. In conclusion, increased time to produce power in the swing can potentially improve bat speed and skill level for baseball players. Starting swing phases in sequence gives hitters more preparation time, more time to generate power, and greater opportunity for contact.